The queue is one of the abstract data type, and it is very similar like stack. Peek function will return the front element from the queue. Dequeue in the sense you will delete an element from the queue. Hello everyone, I welcome all of you to the yet another interesting session in data structure. Yes, what is the topic for the day, sir? It's all about queues. So, are you going to discuss about the queue which we are studying for a vaccine? No, my dear darlings, it's going to be one of the hot topic in data structure. So, yes, what are we discussing in today's session? So, that's going to be the simple queue. So, you just told that, no, we are discussing about the queue, but here you're mentioning it as simple queue. Yes, we have different types of queue. So in today's session, we are discussing the first type of queue, that's going to be the simple queue. So let's understand what exactly this queue is all about before that. So guys, according to the definition, so the queue is one of the abstract data type. And it is very similar like stack. What happens and how it is different from stack, if you ask me, when I take a stack, so guys, do you all remember what we have done with a stack? Insertion and deletion will happen at the only one end in the stack. So everything will happen in this end. Alright. So, but when it comes to the queue, it will not happen like that. So we have got two ends in the queue. So guys, I will treat this as a queue. So this is what I will call it as a front end. This is what I will call it as a rear end. Always the data insertion will happen at the rear end and deletion will happen at the front end. So that's a major difference that you need to remember with respect to the queue. So that is what I will be explaining with this diagram. Observe, this is the queue. So guys, where exactly I'm inserting the data into the queue? Observe, this is what I will call it as a rear end. Always the insertion of the data to the queue will happen at the rear end, in the sense the back of the queue, but deletion will happen in the front of the queue. That's what you need to remember. And what is the principle that we follow when it comes to the queue, sir? So this is what you need to observe. Last in, last out, or you can also call it as first in, first out. So this is the principle that we follow. What is the meaning of it, sir? Imagine this is the first data item which is coming inside the queue. All right. So this will go out first than any other data which has come after this. That's what you need to remember. All right. This is the simple principle that we need to remember with respect to the queue. So moving forward, guys, what are the basic operations that I can perform in the queue? So you're going to expect this question in your exam. So you just need to remember. So let me compare this with the stack. So what do we do in the stack? So remember, you all need to remember this: push, pop, is full. All right. So is empty. So all these things we have discussed, right? So peek. Right. So all these things you remember, right? What is the meaning of push? So push in the sense in the stack, we are inserting an element to the stack, correct? So pop in the sense we are removing the element from the stack. That's what we need to remember. All right. In the same way, observe here, we have a function called enqueue. What is the meaning of enqueue? You are trying to insert an element into the queue. So that is what we call it as a enqueue. The same way we have dequeue. What is the meaning of dequeue? Obviously, you would have guessed it by now. We are trying to remove or delete an element from the queue. So that operation is what I will call it as a dequeue. In the same way, guys, peek. So you all know we have already studied the peek function in the stack. What exactly peek function is doing in the queue? So let's understand what it was doing in the stack. So peek will always return the top element in the stack. But what happens with the queue? Because we have two ends. So guys, peek function will return the front element from the queue. That's what you need to remember. So guys, remember, gets the element at the front of the queue. So here in the stack, top of the queue. So here in the queue, front element. So front element in the sense what? Imagine this is the queue. So front element. Say for example, if it is, this is in the front, or assume that I have not deleted this. So this is in the front. Okay. My front pointer is here. So if I perform peek operation, this element will be returned. That's what you need to remember. So in the same way, guys, the next option, the next function or the next operation is full. Is full here also works same. It will just tell me whether the queue is full or not. In the same way, is empty will check whether the queue is empty or not. So this is the different operations that we perform with respect to the queue. So let's understand these operations one by one. Okay, so guys, I have peak. That's the first operation which I'm going to demonstrate with the algorithm and snippet. So what exactly it is doing? So guys, observe here, I have a procedure. So I will call it as an algorithm or a procedure. So what happens is, the name of the procedure is peak, which we all know. So what happens in the first beginning of the procedure peak? So fine, what is the code that I have? It returns the front element of the queue. So that's what we have written in the queue. Okay, so what I have in the front of the queue, so that element will be returned. Okay, that is what they have given in the procedure. Same way, so observe here, we have a code. Okay, so what is that? This is the return type. This is the name of the function. What is the name of the function? Peak. So I have a return keyword. So this is the name of the array. Okay, that I'm using queue as the name of the array. So I can also implement the queue using the array. That's what you need to remember here. So fine. So, and this is the index. What you have in the front of the queue, that element will be returned. This is the snippet that you need to remember with respect to the peak. Moving forward. So guys, observe algorithm of is full. I'm just checking using is full. What is the meaning of is full? I'm just checking whether my queue is full or not. How do I know that? How do I check that? Observe here, I have the algorithm. So what is that I can do is, this is the beginning procedure is full or not, is full or not. I'm just checking, okay? This is the beginning of the line. So here, observe if rare equals to max size minus 1. What exactly it means, sir? Observe, whenever I say queue, so you need to imagine like this. My front pointer is this and rear pointer is this. So now I'm comparing maximum size minus 1 because I'm using the arrays. That's what you need to remember. So always I should take minus 1 to the size, okay? So if rear pointer is equal to maximum minus 1, then I will say true. Else I will say false. If this condition is true, I will say that my queue is full. Otherwise, if the condition returns false or if the function returns false, my queue is not full. This is what the function is doing. That's what you need to remember. Moving forward to the next one. So that's what we have written in the code. It's same like what we have done. So since I'm using the return type as bool, the function name is full. So here you observe, I'm checking the if condition. So what exactly that I'm doing? Rare is equal to maximum size minus 1. Okay, maximum size minus 1. That's the size of the array. Okay, that's what we have given. So guys, if this is true, it will return true. So otherwise it will return false. If the condition returns true, what is that you will think? The queue is full. So hope this code is very simple for you to understand, my dear students. The next function that we have is empty. So guys, how do we check whether the queue is empty or not? So we need to understand two important conditions. The first one that we have is, so please observe, front is less than 0. So guys, when this will happen, let me just show you. Imagine, how do we implement this queue? We will implement this queue with the help of array. So let me just show you that. So imagine this is the array. Always the first element will be pointed with the front. Okay, so imagine my front pointer is here and my rear pointer is here. All right, so fine. What is the first condition that we have? So when my front pointer is less than 0, so in this case what happens is my front pointer is here and my array is here. Okay, so when my front pointer will be less than 0, when it is having the negative value, so I can easily say that there is no element inside the array. That's what you need to remember. That is the first thing that you need to remember. That is the first condition that you need to say that. So the queue is empty. And along with that, whenever the front pointer is greater than rear, so your rear pointer is here and the front pointer is greater. So even in that case also, so my dear students, you can easily say that your queue is empty. So as soon as you start inserting an element to the queue, the rear pointer will get incremented. That's what you need to remember. So this is how the things are happening. in the queue. So moving forward to the next function that we have. So what are the next function that we have? Enqueue. This is very, very interesting that you need to remember. Enqueue in the sense insertion of an element into the queue. That's what you need to remember. So what are the steps that we need to follow whenever you are inserting any element to the queue? So guys, we have listed out some of the steps what we need to follow whenever we are performing the enqueue operation. Let me just explain that first one by one, step by step, and then I'll show you the algorithm. You will find it very simple to understand. So guys, what happens here when it comes to the enqueue? The step one, the first thing before you start inserting an element into the queue, what is the first thing that you need to check? The first thing that you need to check is check if the queue is full or not. So that's the first thing that you need to remember. So why? Because if the queue is already full, so you cannot perform the insertion operation because there is no space. So for that reason, what happens is, first I will check whether the queue is full or not. Then after that, what I will do is, suppose if the queue is full, so I will say that the queue is overflowing. So that there is an error message will be printed. So queue is already full, so you cannot insert. That's what the second step says. And it will ask you to exit from the insertion. So fine, what will happen with the step 3? If the queue is not full, so this is I'm checking. First I have to check whether it is full or not. So fine, you have checked it. So the third step, so suppose if the queue is not full, what should I do? Observe here. If the queue is not full, increment the rear pointer. That's what you have to do. So imagine this is my queue, okay? This is my front, this is my rear. So I'm inserting an element here according to the array, all right? So now again I'm incrementing. So why are you incrementing? Because you are inserting an element, okay? The rear pointer will get incremented. So it is moving from here to here. So why? Because you are inserting one more element. Always you remember in the queue, the rear pointer will start incrementing or it will start moving. So let me just show you that how exactly it is happening. Imagine, so I have the array, okay? So now you have inserted the first element, okay? So fine, I have 10. So where is your front pointer? You have your front pointer and also you have your rear pointer. So fine, both are pointing to the same element because you have only one. So now I will again insert the second element. So my 20 is here. So where should you have your rear pointer and front pointer? This is very interesting. Imagine my front pointer will always point to the first element and my rear pointer should always point to the last element. So my rear pointer will get incremented from this position to this position. So fine. So I will insert one more element. So what happens? 30 is the next element which I'm inserting. So what happens? So guys, whatever the rear pointer I have here, so it will get incremented to this position. So the rear pointer will start moving. This is the concept that you need to understand. So in the implementation part, but when it comes to the concept, so it is reverse. You will just learn like this. You have the front and you have the rear. So the concept wise it is reverse, but whenever you are implementing using arrays, it is reverse. That's what you need to keep it in your mind. So whenever you are writing the program, so you'll get confused. So don't get confused. You need to remember this. All right, because we are using the arrays to implement the concept of queues here. All right, that's a point that you need to remember. So fine, we understood the third point. What third point says? If the queue is not full, increment the rear pointer so to the next empty space. So fine, we did that and add the data element to the queue location. So whenever you are inserting, so the data will be added to that particular location and return success. This is how you will be inserting. So let's check out what exactly the program will be there or a snippet will be there for the enqueue operation. So before that, so I have some diagram. Observe here what happens with respect to the diagram. All right. So what I have explained here is with respect to the code, but what I have here is with respect to the concept. All right. So always we treat in the concept this as the front end. So that's what you need to remember. So insertion will always happen at the rear end. So that's what you need to remember. So fine. So guys, so after enqueue operation, your queue will look like this A, B, C. Okay, so now, so once I perform this operation successfully, so my queue will look like this. That's what you need to remember. Okay, once I'm done with the insertion of an element to the queue successfully, my queue will look like this. That's what you need to remember. So fine, moving forward, how exactly the code look like. So observe here. So first thing, as we discussed the step 1, so I will check so whether the queue is full or not. If it is full, I will just return overflow. So there is no space for the insertion. Suppose if it is not full, observe here. So here, rare plus 1, the increment for the rare pointer will happen. So in that particular location, so I will save whatever the data that I have. So I will save it to the queue. That's what we are trying to do here, and then return true. So this is a very, very simple code that I'm trying to give it to you so that you will easily remember. So part by part, you start learning, you will find it very, very easy. All right, this is how we perform the enqueue operation. So the same thing I have converted into a code. So the same thing what we had there. So we have given it in the code. So what is the function name here? So this is what I will call it as a return type. Okay, what is this? So this is what I will call it as a return type. So this is the name of the function. So here is the parameter. So what is the meaning of parameter? What is data here? So data in the sense which element that you wanted to insert, that I'm passing as a parameter. What type of data that you are passing? I'm passing the integer type. Your value, whatever you are passing to the queue, should be of integer type is what you need to remember here. So fine. Here I'm just checking whether it is full or not. So fine. If it is not full, I will execute the else part. Same code, I have it here. That's what you need to remember. This is for the enqueue. Moving forward to the dequeue, it is just the opposite way. So what is the first step that I have to perform? Dequeue in the sense you will delete an element from the queue. That's what you need to remember. So guys, dequeue, what is the first step? So guys, whenever you are trying to delete an element from the queue, first you will check whether the queue is empty or not. Suppose if it is empty, so you will not be able to delete any element from the queue. That's the second point says. With the saying an error message, so you will stop and exit from there itself. Suppose I have an element in the queue. So what should I do? That's a third step that we are trying to do. If the queue is not empty, so guys, access the data where the front pointer is pointing. So remember, always the insertion will happen at the, come on, tell me, rear end. Deletion will happen at the front end. So access the front item what you have, which is pointing by the front pointer. That's what you need to remember. So then after that, increment the front pointer to the next element. So how exactly it happens? So let me just show you that with the diagram what I have. So guys, this is a queue that I have. So what I'm trying to do is, so if my front pointer is here, if I want to delete this, so I will shift this pointer to this. I will shift this pointer to this, so that will be treated as you are trying to delete this element from the queue. So I will start moving the front pointer. I will start incrementing the front pointer. That's what you need to remember. So in the dequeue. So observe here what happens. Observe here what happens here. So guys, my front pointer will come to this position. Suppose if I have here, I've just taken a D, you just E, so you just ignore this. So imagine I have only this queue, okay? This is the queue. So this is the queue that I have. So imagine in this queue, what happens? I will remove this A, so my front pointer will be pointing to this B and rear pointer will be pointing to D. So this is the thing that you need to understand. Suppose if I delete even this B also, what will happen? My front pointer will point this C. That's what you need to remember. But the rear pointer will be there as it is. It will not move. So it will be pointing the D itself. That's what you need to remember. So this is how we delete an element from the queue. All right, let's check out the code. This is the algorithm that we have. So first, what is the first thing that I will check? Observe here. So I will check if the queue is empty. If it is empty, I cannot delete. So I will throw an error message saying that return underflow. So fine, if it is not empty, so what should I do? So observe data is equal to whatever I have queue front. So observe what is the meaning of it. So whatever the front is pointing, so that data I will store it in a variable. That's it. I will not do anything else. Then after that, what I will be doing is, so observe, I will increment the front pointer by 1. So that is what I'm trying to do here. So from here, I'm incrementing the front pointer. So then after that, return true and successful. That's the performance that you are doing, so to delete an element from the queue. So fine, after that, so the same code is what I have here. Observe here, this is the return type, name of the function. So here you have isEmpty function. Then if this queue is not empty, you will go to the else part. So here, what is that we are trying to do? The element what we have with the front of the queue that we are trying to store in a variable. That's data. Then after that, we are trying to increment the front pointer. So, and then I'm just returning the data. That's it. So this is going to perform the dequeue operation in the queue. So hope you understood what is enqueue and what is dequeue. Moving forward to the applications, where exactly that I can apply this concept. During the CPU scheduling, CPU will be having a lot of process which will be running. So guys, imagine I have one processor. Imagine I have one processor, but I will have millions of processes. So which needs the processor? So who should go to the processor first? So I will be deciding with the help of the concept called queue. So there I will be using the concept called queue. That's what you need to remember. In the same way, I will be using the disk scheduling. So I need to allocate the disk to the lot of processor. So again, I have to use the concept of queues. So probably if you have studied the operating system properly, you would have come across with this concept. So who should occupy the space first? So I will be using the concept of queues there also. In the same way, guys, print spooling. So I have the printer. I need to print a lot of documents. So one by one. So I will give the print documents. So that printing documents will be in the queue. So that's what we will call it as a spooling. One by one in the temporary memory of the printer. So it will be in the queue. So there also we are using the concept called queues. In the same way, so we will be handling the interrupts in the real time. So one by one now we will be handling the interrupts. Interrupts in the sense what? I'm teaching, I'm taking class to you. So in between, somebody will come and disturb the flow. That's what we will call it as interrupts. So to handle this kind of interrupts also, we will be using the concept of queues is what you need to remember. Lastly, so I have, if I want to transfer the asynchronous data, so I will also use the concept of queues is what you need to remember. So guys, with this, I have come to an end of the simple queue. In the next class, I will be discussing the different types of queues like circular queues, doubly ended queues, and also I will be discussing the priority queues. So till then, take care. Bye-bye. Happy learning.